Hello folks, let's create MCP servers using Java Spring support. Before we understand how to create MCP servers in Spring, it's good to know what MCP is. MCP is a standardized protocol that enables AI models to interact with external tools and resources in a structured way. It's a model context protocol. Using MCP, Java has provided an SDK, which is a Java implementation of Model Context Protocol, which enables standardized interaction with AI models and tools, both in synchronized and asynchronized pattern. Using Java SDK, Spring has provided us a capability to create MCP servers in Spring application, and this Spring AI extends the Java SDK with Spring Boot integrations for creating both client and server. It's good to understand the protocols, since in this video we will be creating servers, but ideally there will be an MCP client which will interact with your MCP servers, and the transport protocol in this can be an stdio or server sent events. If we look closely what stdio transport is, if your application is running locally on a single process, you can use it. SSE is over HTTP. If you are planning on using HTTP, Java does provide 3 different libraries on creating an SCC connection. Let's take a final look into what SCC and stdio are. So for SSE events, which is over HTTP, there will be a client application which will be interacting with your server application. And on a very high level, a client application, say, can be a Java LLM application, which will create an MCP client using the MCP client APIs or a library. And again, you can specify the library, which can be HTTP client, Webflux, or WebMVC. And similarly, on the server side, which we will show how we can create servers, you will create your Java Spring application. And I'm assuming this Java Spring application be running on a web container. In that web container, you can set up your MCP server. And again, since we are over HTTP, you will implement SSE protocol for this. And once you have this server enabled on your Spring application, you can define tools. We can see how we can define tools in your Spring application. And these tools can be either you are connecting with your DB or a different application altogether. You can define n number of tools, and these are exposed via MCP server, which is in your web application, Spring web application, which you are running. And on the other side, if you are using stdio, everything can run in a single process or a same machine. Your Java application can be there, and you can connect your Java application to Java MVC client, and your MCP server can already be running in the same process. And this is more like you are trying to connect to your local file system or file store. So this is useful for those kind of scenarios. Let's look at the different libraries which Spring AI provides for creating MCP servers. These are the 3 different flavors of libraries that we have. This one is primarily used for stdio transport support, and this is for creating HTTP client based on WebMVC or Webflux. I will be using WebMVC in this tutorial. Few points which we need to understand before creating MCP server is SSE and sse-message. There are 2 different endpoints this MCP servers support. These are really crucial to understand the overall working on it. What is SSE? SSE is a client establish a persistent, a long-lived HTTP connection to receive a stream of events from the server. So SSE is used to initialize the connection from the client to the server so that server can constantly send stream of events to the client. This endpoint is primarily for the unidirectional server to client communication. So this is more one-sided so that server can constantly set stream of events to the client, but to complete the overall communication, there has to be a way in which client can also send out any messages to the server. This is where the sse-message endpoint comes into the picture. Application often needs a way for the client to send requests or messages back to the server. This allows the client to communicate it needs, send data or trigger action on the server, while server continues to push event to the client via SSE endpoint. We will look at the example on creating the MCP server. These are the three different modes which I will be using in testing my MCP server that I have created. You really don't need to create a client, but these are the quick way you can test your MCP servers. Let's probably look at the code first. We'll start with the POM. So this is the code that I've written. You need to add one of the three dependencies that I've talked about. This is the dependency which I am using, WebMVC, and this is the version that I'm on. That's it. If you add this dependency, you should be able to code. Before looking into the code, these are the configurations that I have added. You can name your MCP server whatever name you want. This is the version. You can define async or sync capability that we have. Again, these are the messages endpoint and the SSE endpoint that I explained. This will be used to establish an initialize connection from the client to the server, and this will be used by the client to send messages whenever there is a need from the client side. And I'm just enabling all the capabilities that MCP provides in this application. Let's look at the controller. In this controller, this is the endpoint, but I've also annotated this with an tool annotation, which comes from the library that I've imported. And I've given this tool a name and a description what it does. This tool takes in an input and encodes the string that we get into base 64 encoding. That's a very simple example to showcase what we are trying to do. And once you have tool, you can define n number of tools either in this file or any other file. It doesn't have to be a controller file. But once you have defined the tools, you need a way to expose all those tools. So you need to write this configuration, which takes in those classes under which you have written your tool. So currently I have written my tool under this class. So I've just added this class to the tools object so that whatever tools I have created, those will be exposed. Once you have done all these changes, what you can do is that you can just quickly go to your terminal and just bring up the service. So here my service is running on port 8080. So once my service is up, I can use this model context protocol inspector to quickly test out my changes. So I'll start this inspector. Let's see. So now my inspector has started on an endpoint, and I can then use, this is just a UI which MCP provides to quickly test out your application. So this is the SSE transport type that I'm using, and in the configuration I have given SSE for the initializing the connection. I'll just do this. It is able to initialize, and you can go through the response and request that has been triggered because of this action. I can go to these different capabilities. Since I've added the tool, I can click on the tool and I can just list tool. There will be an extra API call that has happened behind the scene to list all the tools. Now after doing that, I see the one tool that I've exposed. It is available here, and it is pretty easy to test it out, and it shows me the documentation, the description that I've added in the code, and I can just do any string, say we rock and anything, and this gives me a result which is encoded. This is how you can use and verify your tool capability that you have exposed through the MCP. Another different way you can use these is in my editor. I have added Copilot, and what I can do is that in my Copilot I can quickly go into the agent mode, and I've already added an MCP server. Let me show you how you can do that. So this is my endpoint which initializes the connection and with the MCP server, and I have just added that. I'm just going to restart this. Once this is restarted, it discovered one tool. Now I can go in here. Since this tool is already discovered, I can close this file. I can just come in here and I can say encode the below string for me, and I say my name Naman, and boom, let's see what it does. It figures out that there is a tool which is available, and this is the name of the tool, and this is the input. I say okay, let's use this tool which is available. And as soon as I hit, and it shows me that the encoding for this string is this. This is awesome. I can test out quickly the tool that I have created using ChatGPT in my IDE. The other way you can do your testing is through the Postman. If you have the latest version of Postman, you would see that Postman does support MCP for testing things out. I have selected this MCP, and in MCP, these are the two different transport protocols that are available to us. I'm going to use HTTP since my example is based on that. I select the endpoint to connect to, and I just said connect. It connected to the MCP server that I've created. It showed me the tool that I've created, which is a string encoder. I clicked on this. I can provide an input. This is the name I want to encode. You can see that it has created the payload and run. As soon as I run, I got my encoding. So this is another beautiful way for you to test things out once you have created your MCP server.